Okay. Good morning, everyone. So, today we are going to start Unit 9, and the first lesson here in Unit 9. We're going to be talking about types and inputs. I'm actually recording this video because I am probably going to be caught up in a staff meeting, but I should be able to get out in time to kind of help you out in breakout rooms. But what I'm going to do is I will record the video of just kind of doing the walkthrough and giving you the checkpoints and stuff, as well as like walking through one of the exercises, and hopefully I can get there and be available in the breakout rooms toward the back end of class, probably like 30 minutes in or so. But I'll have Mrs. Stevens run through this video real quick, just to show you the information, so you can get started on your assignments, and I should be able to help you out toward the back end. We're going to be going over types and inputs. So if you get logged into CMU CS Academy, go into Unit 9, and you're going to go into 9.1.1, which is types. Okay. So one of these things that we actually talk about in types is every time you set up a variable, anytime you're actually using a variable, it has a specific type of variable that it is. Uh, like like it talks about here, the the number 42 is an integer. So if we're setting the value of 42 to a given variable, that given variable also is an integer. So if we say x equals 42, since 42 is an integer, uh, x type is also an integer. So basically, the value of whatever we're actually putting into the given integer, that type, is the same type. So some of the types that we actually utilize in CMU CS Academy are integers, and that's actually written as ints, INTS, but it stands for integer. So we're talking like 42, 0, negative 5. Those are all integers. And then we also have floats, which floats are, it stands for a floating decimal point, or your real numbers. Basically, anything that has a decimal point in it is a real number. So 1.2, negative 5.8, 3.0, those are all floats. And then string values. String values is anything that we actually put like a single quotation on or a double quotation on. So like all those preset colors that we have, like dark green or blue or sky blue, like those all are string values because they have the quotes around them. So those are actually considered strings. Uh, and then and then there's also Boolean, which Boolean is kind of your binary, your 1 0, where it's true and false. So those specific values are, you have to do a capital T, true, and capital F, false. And then there's the none type, which none type, there is only one, which is none itself, and also that is with a capital N. And then specifically in CMU CS Academy, because they have actually set up those types with classes, are all the shapes. So like rectangles, ovals, circles, yada yada. And we can actually take those and set those into a variable, and then they become a shape type here in CMU CS Academy. So if we look at this first checkpoint here, it asks the question, which of these is the following is not a type? So if we look, Boolean is a type, integer is a type, and it says none of these are all types, which is not true because 42, even though it is an integer itself, 42 itself is not the name of the type because that's an integer, and 42 is not a type itself. So we'll submit that. That's good to go. Okay. So now, uh, The one way we can always know that if we're not using our types right is we get a type error when we actually try to run the code. So looking at this code right here, it actually talks about trying to put the radius as whoops. So like if we do run the code, we will actually see that it actually gives us a problem, a type error, because it's trying to use whoops right there as a radius, and that's not going to work. So it basically crashes the code. So the next checkpoint here, we're talking about like it's going to ask you so what like which of the following down here will not give us a type error if we actually replace it, right? Obviously, the whoops does give us a type error. Now, even though -5 is an integer, if we were to put that in there, we're going to notice that something happens. So we run that. It's still going to give us a type error. Even though the type integer is right, it needs to be a positive number because we can't have a negative radius in order to actually utilize the that circle class, right? So what we actually need to do is let's test 50.5. And you would think like, oh, if we put 50.5 in there, it's a floating number. Doesn't it need to be an integer? And when we run it, it actually does not. So if we actually look at this, we see that even with the inspector tool, it does tell us that the radius is 50.5. So we can actually put real numbers in here for our radius and stuff like that. So that actually comes out and it's all good. So click on 50.5 is actually a good value that we can actually put in there. Submit that, and we're good to go. So now, something that we can actually do with our string types is we can actually use the operator of plus to actually put strings together. So you can actually add strings together, and it actually it does it concatenates the two strings together, or basically it takes the first string and then adds the second string to the end of the first string, and so on and so forth. So you can add multiple strings together and basically build a sentence on them effectively. So if we look at this code right here, it talks about actually adding these two strings together. So we set the value of Fred to the name, and then under the label we put my name is, and we add name to it, and it should end up putting my name is Fred, right? So we look at this and we run it, and sure enough, it puts my name is Fred. So we can actually literally come in here, and if we wanted to change change this and put somebody else's name, so I'll put my name and run it. We can see that it does change it, and it changes it to my name is Thomas instead. Okay, so another thing that we can actually do with our types and stuff like that is we can basically convert, or in Python sometimes it's actually called typecasting, but we can actually take a given integer, or we can take integers and actually turn them into a string value, which is a nice little feature, because sometimes we actually need that ability to switch stuff over, because just like we were talking about being able to add two strings together, if we wanted to be able to concatenate these strings right here, we need to make sure that this value that we're incrementing, because it's incremented as an integer, we have to turn it into a string in order to concatenate it right here. Because we can actually run this and see that as we press the key, it's allowing us to actually put that value there. Because if we don't do that, and it actually talks about it down here, It has the question checkpoint 3. What happens if we don't actually convert or typecast that text count to a string? What happens if we run the code like that? So what we're going to do here is show the fact that we're not actually typecasting as a string now. We're going to rerun it, and you're going to see that we end up with a type error because now we're trying to add an integer to a string, and that's just not going to work. So to answer this question right here, we're going to say that, oh no, this code crashes because we're actually going to get a type error because we can't add an integer to the string. So submit that, and we get a yippee. So on to the second part of this, which is we'll talk about like inputs. Now, in Python itself, if we were coding in just strictly Python, there is actually a function called like a keyword called input, where when you call up and ask for input from the keyboard, you're actually able to basically insert a string value. But here in CMU CS Academy, they actually have what's set up called the app get text input. And then this actually pops up a window, does a call up to where the window pops up and everything, but the same thing happens. You're actually entering a string value, right? So if we run this right here, you see that it says enter a message. Say Python is fun. So we send that message, and it takes that string value in there, and it actually does whatever function that it's doing. So here we're running a label, so that when we enter that message, it goes into the app.message value, and it gets stored in that, and then it actually gets used here in the label. So it actually runs that piece of code. Now, so the same thing happens. So when we use that app get text input, it automatically goes in as a string, right? That value that goes in there that we're inputting becomes a string, so it's typed as a string, right? So if we want to be able to utilize that, and let's say we're trying to enter a number and we want to use it as a value as a number, right? We can still typecast and actually do that conversion to make sure that it actually gets turned into an integer. And just like str open parenthesis close parenthesis was how do we convert it to a string, int open parenthesis close parenthesis is how we turn it into an integer. So if you look at this code right here, whatever we're inputting for the radius, right, it goes into app.r, and then we're taking that app.r and we're actually typecasting it to an integer, so we can actually use it as a radius in this code, right? So we run this and we want to do a new radius. Let's do 90. We run it and it does change the circle to actually be radius 90, right? So we look down here at the checkpoint. The checkpoint says, well, what happens if we don't do that typecast? Well, if you just think about it logically, guess what's going to happen? If we take away that typecasting of integer, knowing what happens with the get text input right here, with that get text input, it's automatically going to put in a string value there. So this string value is going to be tried to use in the dot radius, right? So if we run this, most likely we're going to get a type error, right? So if we put 40 in here, okay, yep, sure is enough. We get a type error because that value goes in there and it's actually a string. So it's not going to work because we get an error when we enter the radius. Okay, submit it. Nice job. Okay. So in the previous example, what happens if we enter 20.5 into the circle of radius? So if we go back and actually change this back, or we can just reset this. Don't even have to type it back. So we're going to reset this, and we want to run this code, and we're going to put in 20.5. So if we put in 20.5, before I even hit return and everything to see what happens, if we put in 20.5, the integer typecasting doesn't automatically evaluate and do any rounding or anything. What's actually going to happen is it's just not going to accept it because it has that decimal point, so it actually can't turn this into an integer, right? So if you run it, it tells you there's value error because you can't actually do anything with that because it's not set up to be a normal integer number. It can't be turned into a normal integer number because that's not what it looks like, right? So we're going to come down here and we say we get an error, unfortunately. Submit that and we're good to go. So so we're coming back here to our exercises. So there are a total of 4 exercises here, but Mrs. Stevens and I want you to get 3 points out of this. So I am going to walk through one of these for you, and then I want you to end up doing the other 3 to earn your full credit. So I'm going to come in here and do this Apple Edition one, just to kind of show you. So the goal of the Apple Edition is we're going to print up a couple apples here. We're gonna ask for input of a single digit integer, and then a second single digit integer, and it's going to put on the chalkboard the number of apples, add the second number of apples, and then it's going to give you a total value, right? So I can even show you in a solution. So click here. And I'll show you. Okay, 4, 3. See, we got 4 apples, 3 apples, and it gives us a total of 7. Okay, so that's our goal. That's the goal of what we want to get to. And if you look at all this code, you'll see that everything is actually filled out except when we get down here. And it basically says that we need to actually take the 2 inputted numbers. We need to draw the correct number of apples. We need to modify the value of some result label and statement label to describe the inputted math problem, right? So looking at here at this bottom area, this is where we need to fix the code. So first off, what we want to do is we want to be able to take these 2 inputs that we're getting, because we're getting an input of red apples, we're getting an input for green apples. But remember, these 2 are string values. So knowing that these 2 are string values, first of all, what we want to do is we want to typecast those, right? So in order to typecast those, let's set up some variables and actually put them. So let's call the first one int red apples, and we're going to int num red apples, and then we're going to do the same thing with the green apples. So int green apples int num green num green apples. So now we've turned those both into integers. Okay, so with those integers, now that we have them integers, we can actually utilize this function. So if you look at this function right here, this is what actually draws our apples. And we can actually see that it takes the 2 values, as long as they're integers, right? It's going to take these 2 integer values, and it's going to draw the red apples and it's going to draw the green apples. So this function is already written up for us. So now we just need to utilize it. So this next line, we're going to say draw many apples, and we want to use our two integer values. So int red apples, int green apples. So that should draw up our apples, right? But now we also want, because remember up here it talked about also that we want to have the value in sum result, right? So we need to have this sum result variable as the value of sum result value as, because it's a label, so we want the value of the label sum result, we want it to be the value of the two integers added together. So int red apples plus int green apples. So now, now that we have that value stored in the sum result, we just need to make sure that we're returning the statement that will actually show up to be the bottom statement there that you see, like on the bottom. The 4 red apples and 3 green apples makes 7 apples total, right? So, and they do give us some of that information already. So what we need to do is we need to take this and we're going to put, we have our num red apples is the original amount as a string, right? And then we want to add the word red apples and then we want to add num green apples add green apples makes and then we want to add the sum, but remember that sum result is actually the sum result dot value is actually an integer because we added the two integers, so we need to recast that as a string, right? So we want that recasted as a string. And then we're going to add that last little bit. So that should give us that final statement of all of that stuff, and make sure we close the parentheses on this. So looking at that, that should actually be it. So we're taking in the two inputs as string values, and then we are uh, taking those two strings and we're turning them into integers. Then we're running the function with the two integers to make sure that we draw the right number of apples. And then we're taking those two integers and adding them together, turning it into the sum result, right? And then we're writing the statement to where we have the number, the integer that we're using, and it's saying that's many red apples, and the number of green apples, which is a string, and then it's still adding the other string of green apples makes. We're typecasting the sum result because this is an integer value right there. We're typecasting it into a string, so we can put that value there, and it says apples total. So with all that, we should be able to run this, and we should be able to check it. So let's say 2 okay plus 5 okay. 2 plus 5 equals 7. It looks good. Looks like it should run. So let's check it. And boom. AutoGrader says we're good to go. And there we go. So that is how you do the Apple addition one. So now I want you to start working on the other three assignments there, the other three problems in the assignment there, and hopefully I should be available to walk through this with you, to walk through the others with you, but until I get there, obviously Ms. Stevens can help you out, and hopefully everything goes good, and I will see you soon.